Hello everybody, and welcome to the first in a series of preparatory videos that I'm going to be making available for you guys. My name is Dr. Pennington, and you're going to be hearing a lot of my voice through a whole bunch of these videos. My goal for these is to allow you to prepare more effectively for class. So when you go into class, you know what's going on. There's none of, so what are we doing today? I've got no idea what's going on. There are some concepts in chemistry that require a bunch of practice to be able to master, and it helps having a tool there for you that's not just the textbook, so something else than the textbook to help you when you have problems. Okay, so the first video that I want to talk about today is to do with measurement and significant figures, particularly the concept of uncertainty in measurement. I have on this first slide here pictures of two measuring cylinders. Now, one of the things that's going to be key for you to do in lab is to be able to accurately gauge what exactly is the volume of a particular solution or whatever in a measuring cylinder. Now, before we start doing that, let me just put this in a framework that most of you will have an appreciation of. This isn't just some chemistry thing that you have to do because I tell you. Imagine that you go out to the gym or somewhere, or say you go to the doctor's office and you get yourself weighed. Let's say you weigh 185 pounds, for example. Depending on the type of balance that weighs you, the weight that you see is actually going to be potentially different. If you get on one of those digital scales, you might see a weight that looks something like this: 185.0 pounds. On the other hand, if you stand on one of those scales that's more old school and that has the bar on top and the little black thing that you're going to move across until that metal bar stays straight, then that is less accurate and will measure your weight to be this. Now, I know that both of these numbers look to be the same, but there is a little difference here. This is more accurate because there's more significant figures in the measurement. The way we go about doing this is, whenever you're measuring something, all the digits apart from the last one are certain. There's no ambiguity about them. The last digit is always the one that has to be somewhat uncertain. It has to be estimated, whether it's you estimating or the machine estimating. And you can generally say that the accuracy of a measurement like that is equal to plus minus 1 of the last unit shown. So, for example, plus minus. Alright, I'm messed up there. Should be plus minus 0.1 pound is the accuracy for that. This guy, because the last digit here is a 5, this means the accuracy is somewhat less, and it's plus minus 1 pound. So the range here could really be between 184 and 186 pounds. The range here would be between 184.9 and 185.1. So clearly a much smaller range here, more accurate value. The idea being, the more significant figures you can put into a measurement, the more accurate it then becomes. Okay, and we're looking for as accurate values as we can possibly get. Okay, so that's a little bit of a framework behind what significant figures are all about. Let's now take a look at these graduated cylinders and actually see what we mean by estimating the last value here. Okay, so let's start off with this one on the left. You can see that this point here is 50 mils. If that's 60, then this line here must be 55. So right off the bat, I can tell my volume here is somewhere between 50 and 55 mils. But I can go one step further. I can say, well, that's 51, that's 52, and if that line is 53, can everybody see that the meniscus here, the lowest point of the level of water, is between 52 and 53. So that means my value is going to be between 52 and 53 mils, which also means that my answer is going to be 52 point something. Okay, and it's this point, the thing that comes after the decimal point in this case, that we have to be careful about, because we don't know what it is exactly. All we know is that it's somewhere between here and here. between 52 and 53. So we have to estimate. Well, you can see that if that's 2 and that's 3, the meniscus is closer to the 3 than the 2. It's not at the halfway point. So that means it's higher than 52.5. In fact, it's close enough to the 3 that I would say is probably either 52.8 or 52.9 mils. So that's what I'm going to say, 52.8 mils. Notice that the last digit here is the one we had to estimate. Did not have to estimate the 52 because we knew that. Let's move over here. Exactly the same thing. Let's get a look at what's going on here. If that's 6 and that's 8 up there, then this must be 7. Meaning 6.2, 6.4, 6.6 and 6.8. So therefore my answer is going to be somewhere between 6.6 and 6.8 mils. Okay. Now again, if we estimate here, we can see the meniscus is very close to the 6.6, but we don't know exactly where that is. So all I can say is my answer is above 6.6, but it's certainly not halfway, so it's not the 6.7, so it's really somewhere between 6.6 and 6.7 mils. And again, because it's nowhere close to halfway, it's going to be closer to 6.6. And so what that probably means, again, we have to estimate at this point, it's quite close to the 6.6 line, so I'm just going to say 6.62 mils. 6.61 will probably be an okay value as well. We always have that little margin of error. So the idea being that, again, that 2 is the one we had to estimate when we were doing our measurement. Okay, let's move on to significant figures now. Actually, before we do that, notice that I have a certain number of significant figures in each of my answers. In this case it's 3 each. We are going to go through a little bit about significant figures and what they mean. I'm not going to spend too long on it though, and we're going to end by doing some calculations and figuring out the correct number of sig figs for each. Alright, so I'm going to start off by just writing out several numbers. 352, 302, and 0.352 and 0.302. Let's do 120.0, 120. So let's just do these. I'm going to be able to illustrate most of the rules just by these numbers. Alright, so simplest idea. When you've got no zeros in your number, everything is significant. So in this case we've got 3 significant figures. In fact, what you'll find is that most of the rules for sig figs come from the location of zeros, because those are the ones that really only vary. If you have a situation where a 0 is located between 2 non-zero digits, it's automatically significant. It's got no choice. It's just sort of there in between. SF of course stands for sig figs here. Now what if we've got a 0 that comes before our non-zero digits? It doesn't matter whether there's a decimal point here or not. Any 0 before non-zero digits is automatically insignificant or not significant. Insignificant makes it sound like it's not nice or something, but anyway, all it means is that it's not significant. Okay, so that means in this case that 0 is not significant, and the only thing that is significant are the 3 non-zero digits, so therefore 3 significant figures. I'm going to go through here and actually underline all the significant zeros here, just so you know, so I'm not going to underline that one. Now this one is kind of an amalgam of these last two problems. This 0 is not significant, this 0 is because of its location, so therefore 3 significant figures as well. Now here we have a situation where we have zeros that come after the non-zero digits. We have the same thing here, but here we have a decimal point and here we don't, and that decimal point makes a difference. Doesn't make a difference for zeros that come before the decimal point, but it doesn't make a difference for the zeros that come before the non-zero digits. It does for these though. If we take a look at this, if the decimal point is there and the zeros come after the non-zero digits, they are still counted as being significant. So what that means is every 0 here is significant, so therefore in total there are 4 significant figures. Okay, if I was to say something like 0.0120, that 0 would not be significant, that one would, and that would be 3 significant figures too. When we get down to this last number, this is where I need to be specific. There's some ambiguity about this number. because in order to answer this, you have to assume whether or not there is a decimal point there, and in some cases it would be assumed that it's there, in some cases it's not. So we just need to make it clear that you want to try and avoid representations like this as much as possible, again because of the ambiguity about the presence or absence of the decimal point. If there's no decimal point there, it means two significant figures, but there's a better way to show this number to avoid this potential ambiguity, and that's to show it in scientific notation or an exponential notation. If there was a decimal point, it would be here. So let's say I want to show this in an exponential format that removes any ambiguity at all. Alright, so before we said the decimal point wasn't here, or we're really not sure, I'm just putting it here to figure out how to get to my exponential format. I've got to move back 2 places here to get the decimal point here, and because my coefficient here is bigger than 1, then that becomes my answer in exponential format. So whenever you get an answer like this, it's better to write in exponential format where the two significant figures are clearly shown and there's no ambiguity about zeros. So 2 significant figures. Alright, so that's a little bit about significant figures. Let's do something very quickly about significant figures in calculations. And you're going to find there are basically 2 sets of rules. Significant figures, or what to do when you have multiplication and division, and what to do when you have addition and subtraction. When you have both, it's a little bit more involved, but it's actually not that difficult. So let's just do this one first. Multiplication and division. What we're looking for here is we can only show the answer to the part of the question that was the least accurate. In other words, we have to round our answer to the smallest number of significant figures possible. And so what we have to do is just count up how many 6 figures are involved in each number. If we count them up, then we've got 5 here, we've got 4 here, we've got 3 here. Remember that these 2 are not significant and that one is, just as these 2 are. And then we've got 3 here, which means our answer has to be shown then to 3 significant figures. So when we multiply all those out, we multiply these 3 together first and then divide the answer by that. Don't do any rounding at this point, so you'll have a bunch of numbers in your calculator, a bunch of decimal places. That's fine. We'll do that rounding right at the end. And what we end up with is, I got this. I got 0.38137. Okay, and it's always useful to put a line under the digit that you know is going to be the last one. I've got to show this to 3 sig figs. That's not significant, so therefore I have to end here, which means my answer to 3 significant figures is going to be 0.38. Now I've got to figure out what to do about this 7 and this 3. Well, the 7 I can just get rid of, but the last number before the last significant figure that we're going to show, basically if this number is 5 or more, this number gets rounded up. If it's not, it stays the way it is. So therefore, because that's 3 to 3 sig figs, that is our answer. Now when we're dealing with addition and subtraction, significant figures is not what we're looking for. It's decimal places, in fact. We have to show the answer of a addition and subtraction problem to the smallest number of decimal places, and so for that reason it actually helps to write a question like this out in a slightly different way. Write it out in the way that you probably learnt in middle school or high school or somewhere school, where you put all your numbers, your tens and ones and point ones and all that in the same column. So what I'm doing is here I'm saying I'm lining up my 0 here, which is in my ones column, with my 2 here that's also in my ones column. I'm lining everything else up. That's a plus sign. This is going to be a minus sign. We're going to put my 12 here. That's going to be 0.02. And then when I go ahead and do all that and figure everything out, that one's there by itself. 8 minus 2 is 6. 8 plus 1 is 9. 2 minus 2 of course is 0. 3 minus 1 is 2, and then we have that. So that's our answer, 120.961. But again, we've got to figure out to how many decimal places do I show the answer. Well, in this case it's not that hard. We had 3 decimal places here, we had 1 here, we had 2 here. So therefore we show it to the lowest number, which is 1. Which means 120.9. We can get rid of the 1, but when we have to get rid of the 6, remember the rounding business, 6 is bigger than 5, so when we get rid of that we have to round up the 9 to a 10. Of course, when we round up that 9 to a 10, this becomes 121. Because we're doing this as 1 decimal place, it's 121.0. Alright. Now, what about when we go ahead and do this for problems that have both multiplication and addition or subtraction? Because then potentially the 2 rules will counteract each other and you'll start to wonder what on earth is going on. I'm scared. Well, hopefully you won't say you're scared. I don't know, maybe you will. Alright, let's just tackle that first one at the top and get that out of the way. What I would always do is just do all the stuff in brackets first before you do anything else. So when you multiply all those out and then divide by this and divide by this plus this, what you get is, well, what I get is an answer of 1.1742 7. Right. Now, here's the issue. Okay, we have the decimal places business and we have the significant figures business. The significant figures business is actually more important than decimal places when you're doing both of these operations together. So we're still going to look at all of our numbers and see which one has the lowest number of significant figures, regardless of decimal places. So here we have 4 significant figures. Here we have 4, here we have 4, and here we have 5. Which means that the number of sig figs that we show the answer to is going to be 4. So therefore 1.174. Because of that 2, we don't have to do any rounding up, so therefore that is the answer to 4 significant figures. Now let's do one more down here. Again, we have exactly the same issue. We've got multiplication and we've got addition. Alright, but again, the significant figures from the multiplication take precedence over the whatever we do as the result of the addition. So we've got to look at significant figures. Here we've got 4, here we've got 4. Do we have 2 here? No, if you remember, we don't have 2, we only have 1. Which means our number of significant figures that we've got to show in the answer is actually only 1. Now when we do all that, this ends up being 3.603 plus 4.811, and when we add all those together, what we get is 8.414. Again, we have to show the result to the least accurate number in the question, which is 1 significant figure here, so we get rid of the 4 and the 1. And in getting rid of the other 4, 4 is less than 5, so therefore the 8 doesn't need to be rounded up, so therefore the answer to 1 significant figure is 8. Alright. And that is how you deal with significant figures in calculations. I hope this has been somewhat helpful. This sort of thing you're going to get better at just by practicing and practicing and practicing until it's coming out of you, well, until you know what you're doing. Alright. Okay, well, that's the end of this first video, and I hope that it's been useful.